Number 18 from 8.5 worksheet 1. When you look at something like this, what you see is a whole lot of complication, right? What I want you to do is I want you to take it numerator and denominator. So what you're going to do is you're going to have the numerator divided by the denominator. You're going to write it in that manner, okay? So my numerator is going to be 5 over x plus 3 divided by 2 plus 1 over x plus 3. We all see that, yes or no? Now, 5 over x plus 3, can I do anything with that? No. When I'm dividing, I can flip the fraction and change the division to multiplication, correct? Before I can flip a fraction, I have to first make it into one fraction. How many terms do you see here? 2 terms. I can't do that until I make it one fraction, one term. Do we understand that? So what we're going to do is we're going to keep the 5 over the x plus 3, and we keep the division sign. We're going to put the 2 over 1, and we're going to ask ourselves, what is the LCD between 1 and x plus 3? X plus 3. So what we want to do here is we want to turn this denominator into x plus 3 and this denominator into x plus 3. So what did I multiply 1 by to get x plus 3? So I bring down the 2 and I multiply by x plus 3. Do we see that?
Yeah.
1 times x plus 3 is x plus 3. What did I multiply 1 by? X plus 3. What I do to the bottom, I do to the top. I drop down the 2. Now, this already has x plus 3, so I simply drop down the 1. So according to yesterday's lesson, I told you that if we have 2 fractions, we need to first get a common denominator, meaning they get engaged, they have the same denominator. And then after you get engaged, the next thing you're going to do is get what? Married. When you get married, you are going to live in one house, which means you are going to move in together. So that house becomes my one denominator, which is x plus 3, and then I bring down each person's numerator. This numerator is going to be 2 times x plus 3, and this numerator is going to be 1. Now, when you finally move into one house, his stuff, her stuff, they're all in boxes, right? Boxes are all in the living room. What do you do with your boxes? You unload the boxes, right? According to this problem right up here, what would be representative of our boxes? The parentheses. Parentheses are our boxes, so we need to get rid of the parentheses by doing what?
FOIL.
Distributing or FOIL. So this gives me 2x plus 6 plus 1 over x plus 3. Do I have any like terms? What is 6 plus 1? So I'm going to have 2x plus 7 over x plus 3. Now, am I dividing by one fraction? Yes, I am. So what can I do? I can take the reciprocal of my second fraction, change the division to multiplication, and now I'm multiplying by x plus 3 over 2x plus 7. Now, do you remember in section 8.4, did we cancel out first, or did we do our domain restrictions first? We did our domain restrictions. So what is my domain restrictions here? X cannot be what?
Negative 3.
Negative 3. Or, how do I get rid of the 7?
Negative 7 over 2.
Negative 7 over 2. So there's my domain restrictions. And from left to right, do I have a 5 in the denominator? Do I have an x plus 3 in the denominator? Yes. So what am I left with?
5 over 2.
There's my answer.
Yeah, today.
Do we understand how to do the back now? Tonight's worksheet is what I'm handing to you now. Nope, just the evens. Tonight's worksheet, I want all of it done. So number 1 on tonight's worksheet, I give you two fractions, 5 over 6ab minus 7 over 8a. Now, I need these two fractions to get engaged. So how do I go about doing that? I need to find the LCD. So I find my largest number in the denominator, which would be 8, and I start doing my multiplication tables. 8 times 1 is 8, 8 times 2 is 16, 8 times 3 is 24. And then I look at my smaller numbers. 6 times 1 is 6, 6 times 2 is 12, 6 times 3 is 18, 6 times 4 is 24. What's my first number that they have in common? 24. Do we all understand that? Now, in order to do this, you have to have each of the things, each term represented in your LCD. So, do they both have an A? I take the higher exponent. Well, it's a to the first, and a to the first is going to be simply a to the first. Do they both have a B? No, but I need the B. So my LCD is going to be 24AB. Do we all agree with that, yes or no? I need this denominator to be 24AB, and I need this denominator to be 24AB. I drop down my 5. Now, what did I multiply 6 by to get 24? I multiplied by 4. Do they already have an A and a B? Yes, so that one's done. What do I multiply 7 by? Whenever I had my 8, I multiplied it by what to get 24? Once you do the bottom, you do the top. This one has an 8A. What is missing from the bottom to... I need a B, don't I? So I need to have a B on both the top and the bottom. Do we all understand that? There's an 8 and an A. There's already an A. There's not a B. So that's why I have to add it. Okay? Now, what do I do here? They're engaged. Now what do we do after we're engaged? We get married. So we're going to live in one house. So I have my house is going to be the 24AB. Do we all understand that, yes or no? Okay, so now, with that said, I'm going to bring his stuff and her stuff into the house, yes? So what is 5 times 4?
20.
20.
Minus 21.
7 times 3 is 21B. Do I have a GCF there? No, I do not. So this is done. Now, I need to find my domain restrictions. Well, that means my denominator cannot be 0, which means 24 cannot be 0, A cannot be 0, and B cannot be 0. Can 24 ever be 0? No, so this one is irrelevant. But what are my domain restrictions? A cannot be 0 and B cannot be 0, because if it is, then that means that I'm dividing by 0. Can we ever divide by 0? Okay, let's go on to the next one here. Number 3. Number 3. Now, A minus 3 is a head and a body, correct?
Yes.
Wherever the 3 goes, the A goes. Wherever the A goes, the 3 goes. Wherever the A goes, the 5 goes. Wherever the 5 goes, the A goes, right? Okay, what is my LCD?
3 and 8.
A minus 3 times A minus 5. Very good. So if that's going to be my LCD, I need each one of these fractions to have that denominator. Do we all see that, yes or no? That's what would make them be engaged. They have the same denominator. So, check it out. A minus 3, A minus 3. What did I tack on to that denominator? So once you do the bottom, so that means I drop down the 4 and I multiply by A minus 5. Go to the second one. I have an A minus 5 and an A minus 5. What did I tack on to it? So I drop down the 9 and I'm going to have A minus 3. Does everybody understand where those terms all came from? Okay, now, they're engaged. What's after engaged? Get married. So now we have one house. We move in together. I have A minus 3 times A minus 5. I bring down his stuff. Is it okay if I distribute? That gives me 4A. minus 20. I distribute over here. First up, 9a minus 27. Does everybody understand what I just did up there? Do I have any like terms? What's 4a plus 9a? 13a. What's negative 20 minus 27? All over a minus 3 times a minus 5. Can I pull out a GCF or factor that into another binomial?
No.
No. So that means this is done, but what do I need to find yet? So what can a not be?
3 and negative 5.
3 and negative 5. Do we understand that, yes or no?
Or 3 and 5.
3 and 5. Sorry, positive 5. Thank you. I just read it wrong. We good? Okay, well, what's going on with number 5? Why does this one look different than the other two that I've done? Because for number 5, the denominators are not factored, are they? The GCF hasn't been pulled out if there is one, and they're not put into two binomials either if there is one. Or if you can, I should say. So, let's first see if possible if we can do any of those. So this 5 I'm going to bring down. Can I factor 2x minus 12?
Yeah.
What is that going to be?
X plus 6. Or no, I don't know.
2 times x minus 6.
Good job, Tyler. 2 times x minus 6. That's exactly right. Do we all understand that the GCF is a 2, so you have to pull it out? Now, do you like addition or subtraction better? Addition. So what we're going to do is we're going to change that minus to a plus, and we're going to distribute that to make that a negative 20. Do we all understand that? That way, we never have to worry about distributing a negative to an entire quantity. We just change the positive 20 to the minus 20.
Why wouldn't that go to the denominator?
It goes either to the top or the bottom. Would it be easier to go to the top, which is a single number, or to the bottom, which is a trinomial? Does that make sense?
Yeah.
It doesn't matter if you go to the bottom or the top. If you go to the top, you just take both portions out. Yes. You can't go to both because if you have a negative divided by a negative, it turns into a positive. That's why you can't do both. Okay, now, the second denominator. What do I do with that?
You factor it.
I need to factor that into two binomials, so tell me the two binomials that's going to be. Please think before you speak. Please think before you speak.
I'm thinking out loud. I just get the sign screwed up, so that's why I don't say it. I know the numbers.
Very good, Timmy. X minus 6, x plus 2.
Yeah, we said it there.
Okay? The 12 is negative because negative 6 times 2 is negative 12. Inner gives me negative 6x. Outer gives me positive 2x to give me the negative 4x. Now, everything's factored completely. Is this a true statement?
Yep.
Now, what's my LCD?
X
2
plus
times
2 times x minus 6, which is the first denominator.
X minus 6.
Why do I not need to write the x minus 6 down 2 times?
You have it.
Because you are taking the higher exponent, and guess what? Since they both have the same exponent, you don't need to worry about it. We understand that. So I need each one of those denominators to turn into that. So I need to have 2 times x minus 6 times x plus 2, plus 2 times x minus 6 times x plus 2. Now think about this. The 2 and the x minus 6 are here, so what did I tack on?
X plus 2.
So I bring down the 5 and I tack on the x plus 2. Over here, I have x minus 6 and x plus 2. So what do I need to tack on? Negative 20 times the 2. The negative 20 I just drop down. The 2 I have to tack on because that's what needs to get a common denominator. Are we all good?
Sure.
Okay, now, we're engaged. How do I know we're engaged? Because they have the same denominators. And after they have the same denominators, what can I do?
Get married.
I can get them married because I'm just going to write this as one fraction with the house being the denominator. So the denominator is 2 times x minus 6 times x plus 2. Can I distribute?
Yes.
So that's going to give me 5x plus 10 minus 40. Now what should I do?
65.
Combine like terms. What is 10 minus 40?
30.
Minus 30 over 2 times x minus 6 times x plus 2. Am I done? Why now?
And your bottom's not.
What is my GCF in my numerator?
5.
A 5. You need to pull that out. So if I pull out a 5, I'm going to be left with x minus 6 all over 2 times x minus 6 times x plus 2. Now my question is, in previous sections, did we cancel out first or did we find the domain restrictions?
I mean,
We found the domain restrictions. So what can x not be here?
-2.
It cannot be positive 6 or negative 2. Do we all understand that? Yes or no? You see it? Now from left to right, do I have a 5 in the denominator?
Yes.
Do I have a 5 in the denominator?
No.
No. Do I have an x minus 6?
No.
Yes.
Yes, I do. So what am I left with?
5 over 2 times x plus 2.
Can I do anything with that?
Okay, 1.
Do we all understand that? Turn it over. Number 9. Number 9 looks ugly, doesn't it? But is it really that bad? Not if you tear it apart, right? How do I tear it apart? What does that mean? Numerator divided by denominator, right? So what is my ugly numerator?
R plus 6.
Parentheses, please, divided by r squared plus 4r plus 3 divided by r squared plus r. Question. Can I turn my division into multiplication?
Yeah.
Easy, you say yes. Why? When can you flip it?
Oh, 3.
Okay, well let's go back to the problem that we did, the first problem. Were we able to flip this one right away? Why? Because I had 2 terms, it was not one fraction. Do we understand that? I flipped it. I flipped it right here. We see that? It went from division to multiplication right here. Why was I able to flip it there? It was one fraction. I don't care about the same denominator. I care about that I'm dividing by one fraction. So if we go back to the problem that we're doing now, am I dividing by one fraction or 2 fractions? I'm dividing by one fraction. So what can I turn that into? I can turn that into multiplication, can't I? So this junk over here of r plus 6 over r minus 1 over r plus 2 hangs. The division turns to multiplication. And now I'm going to do what with this fraction? So that's r squared plus r over r squared plus 4r plus 3. Do we understand that? Why did I drop parentheses around the second fraction but not around the first numerator? Because the first set of parentheses has 2 fractions attached by subtraction in there, correct? So I need to make that one fraction before I can drop those parentheses. Do we all understand that? So now, I need to find my LCD between r and r plus 2. R times r plus 2. Do we all understand that, yes or no? Okay. So I need an r times an r plus 2 here, and then an r times an r plus 2 here. Now, I changed this to plus, so what does that mean I have to do up here? That's a plus and that's a minus 1. Do we all understand that? So what did I multiply r by to get r times r plus 2? So I bring down the r plus the 6 and I tack on the r plus the 2. What did I multiply r plus 2 2 by to get r times r plus 2.
R.
So that's going to give me negative r. Do we all understand that, yes or no? Now I'm not even going to acknowledge the rest of that stuff over there. I'm just going to keep on working this part right here. So now, do I have the same denominators?
Yes.
So they are engaged, correct?
Yep.
So what do? Marry them, make them one fraction. So that's going to give me r plus 6 times r plus 2 minus r. Now what? Not even worried about that one yet. Don't worry about that second part of it yet. What should I do?
Foil that.
FOIL. So that's going to give me r squared plus 2r plus 6r plus 12 minus r all over r times r plus 2. Combine like terms. So that's r squared, 2r plus 6r is minus 1r is 7r plus 12 over r times r plus 2. Put that into two binomials. That's r plus 4, r plus 3, all over r times r plus 2. Now this is factored completely, isn't it? So I'm going to go back up to my denominator, and I'm going to start factoring that one. So I need to factor r squared plus r. So what's that going to turn into? Pull out an r, and that's going to give you r plus 1 that's left. The GCF is an r, so pull out an r. Now how do I factor the denominator? R plus 3, r plus 1. Since that's factored, I'm simply going to drop that down. Attach it right down here at our last step. Now, what happens? Do I do restrictions first, or do I cross cancel?
Restriction.
So r cannot be what? 0, negative 2, negative 3, negative 1. Do I have an r plus 4? Do I have an r plus 3? Do I have an r? Yes. Do I have an r plus 1? Yes. So what's my answer? R plus 4 over R plus 2, comma. There's my restrictions. You guys need to make sure that you work on all your problems tonight. Both worksheets. Tomorrow when you come in class, I'll have the answers on the board for you.